Hi everyone, welcome to the Prep Lab, aka the Attic. Today I wanted to show you some acid preparation of this Moroccan nodule here that I'm doing for a friend. What we'll be using is acetic acid diluted in water, and that will react with the calcium carbonate in the matrix of the nodule, breaking that down into calcium acetate, carbon dioxide and water, so that the matrix will break apart and settle to the bottom, revealing the bone. What we want to do is dilute this down from 80% down to about 3%. We might go up to 5% at some point on another cycle, depending how aggressively it's reacting. That's just so that it doesn't react harshly with the bone. Another measure we want to take to stop that from happening is to use a calcium phosphate buffer. Because the bone is made out of calcium phosphate, if you supersaturate the solution with calcium phosphate, then it stops the acid from being able to react with any more of the phosphate. So to create that dilution, we've got about a litre of water here, just under a litre. We want to add 62.5 mils of this acid to the water. And then add the buffer until you just see it start to come out of solution. So about this much, stir a little bit, and then wait for it to dissolve. So the nodule itself has some bone exposed, and what we've done is added paraloid B72 to the outside here in thin layers, just to protect it a little bit more from the acid as well. You can sometimes use wax as well on the outside, but found that it doesn't work as well with these particular nodules. It's all about experimentation though, to see what works. So we can see the calcium phosphate falling out of solution there. That means that it is supersaturated and it's ready for the nodule. Go ahead and put that in.
You can see the nodule reacting very aggressively as soon as we place it in the acid. This is the looser, almost dusty outer layers of the matrix, which have much higher surface area. This nodule contains part of the jaw of a Tethysaurus, a type of primitive Mosasaur from around 90 million years ago. We chose acid preparation for this specimen as the matrix is much harder than the rock, and the bone is frost-weathered, therefore quite brittle, so both air scribe and abrasive techniques were not as effective. This technique is appropriate for specimens where the matrix will react readily with the acid but the fossil will not, which will most likely be examples like this, where you have phosphatic preservation of a bone in calcium carbonate, like limestone or some kind of lime mud. You don't want to use it on non-carbonate mudstones and sandstones, and especially not with fossils that are composed of calcium carbonate, which will include most shelly fossils.
So this is the result after one acid bath. I've left it in water overnight to just prevent the acetate crystals from forming within the pores. You can see where the original bit of exposed bone was here, where the paraloid has started to discolor. We'll just get rid of that with a bit of acetone and apply some more paraloid. Probably give it a couple more rounds of preparation, but I just thought I'd show you what one bath of acid can do.
I'm returning the nodule to the acid for a second cycle, I'll probably do a couple more cycles and show the result in a part 2. If you enjoyed this video, please throw us a like and consider subscribing. See you next time.